you're standing on the ground. Maybe you're sitting, maybe you're dancing. But either way, you're in contact with the one true constant in your life, the ground beneath your feet. You probably think that ground is pretty solid. But in fact, you're standing on a very thin, very fragile crust floating on a sea of magma so hot that if you fell through, you'd be no more than a pile of ash in seconds. Welcome to level 1 of the world's most dangerous dungeon. But even though we've only just begun to descend into the fiery depths, it's already too hot for humans. And this is just the beginning, because the ground beneath our feet is only the first of Earth's many hidden layers, each more mysterious and more dangerous than the last. And yet scientists refuse to stop digging, drilling, probing, and mapping the underground realms that surround us on every side. Because even though we can never hope to see the center of the Earth with our own eyes, we keep pushing deeper and deeper into the planet's fiery heart to uncover its secrets. And what we find down there affects all of us in ways we never would have guessed. So grab your helmet and your hard hat, because we're about to go spelunking into the planet. Scientists have developed lots of ways to peer into the planet as hidden layers without actually having to dig through all that rock. One of the simplest is to listen to seismic waves as they move through the Earth, kind of like an ultrasound for geologists, except instead of high-pitched sounds, they're using much lower frequencies, the kind that humans can't even hear. By measuring how long it takes for these waves to pass through different layers and the subtle ways they change along the way, scientists can map out the composition and density of the materials they're moving through. It's actually how we learned that the outer core of the planet is liquid, thanks to the way seismic waves speed up as they pass through it. But for a lot of scientists, that's not detailed enough. Some want to get their hands dirty, or at least their instruments dirty. Take, for example, the deepest hole ever dug by human hands, Russia's Kola super deep borehole, which reached a maximum depth of 12 kilometers before being abandoned due to, you guessed it, unbearable heat. Even that ridiculously impressive number isn't all that impressive when you consider that it is still less than 0.2% of the way to the center of the Earth. At those depths, the scientists could measure the physical properties of the rocks firsthand, collecting samples to study later. But even that was nowhere near deep enough to satisfy everyone. So some scientists are taking a different approach, literally going around the world to find natural holes that reach much further down. Earth has plenty of giant holes already, but scientists aren't satisfied with studying them unless they can get their hands on some actual dirt. That's why deep-sea drilling projects like the one underway off the coast of Japan are so important. Trenches in the ocean floor can reach depths of 600 kilometers, where the pressure and temperature are so intense that it breaks down the rocks into a fine powder called peridotite. These particles can then be carried by ocean currents to the seafloor, creating a sort of ring of fire around the Pacific Ocean. And within that ring lies the deepest mine on Earth. Here, scientists are sending submersibles over 10,000 meters into the ocean to collect samples of this ultra-hot, ultra-dense rock from the very doorstep of the mantle, back on land. Other teams are taking a completely different approach. They're blasting holes into the planet with giant lasers. Okay, maybe giant is an exaggeration, but it's not by much. These lasers are actually just a tiny part of a much larger particle accelerator that sends beams of light nearly as big as grizzly bears hurtling towards the Earth at half the speed of light. When the laser hits the ground, it creates a small explosion that blasts rock and soil up onto the surface. By carefully measuring the light as it bounces back, scientists can learn all sorts of things about the minerals inside the planet, including how much water they contain and how far down it extends. And finally, all of these techniques are helping scientists understand the deepest layer of all, the one that none of us will ever see, the planet's core. Thanks to neutrinos, these tiny particles can travel through the entire planet without interacting with anything. That makes them perfect for mapping the inner layers of the planet because they basically act like little mole rats burrowing through a maze. Except unlike mole rats, neutrinos don't leave any dirt behind. But scientists have developed extremely sensitive neutrino detectors buried deep underground to measure the particles as they pass through. And because neutrinos travel at nearly the speed of light, they're able to create incredibly detailed maps of the core and tell us things we never knew before. Like the fact that the inner core is actually a giant ball of solid iron spinning slightly faster than the rest of the planet. By combining all of this data, scientists are finally starting to piece together the hidden layers of the planet, one neutrino, one seismic wave, one drill bit at a time. And the more we learn about these underground layers, the better we'll understand not just the incredible forces that shaped our world, but also how these hidden layers shape our world today, from the restless engine that drives earthquakes and volcanoes to the magnetic field that protects us from deadly cosmic rays. The story of the planet's interior is written in seismic whispers and molten fire, and it's up to us to decode it if we want to survive the coming years. Thanks for watching.